The next presentation is to see the graphical user interface of SU2, and very interesting. I'm always very passionate about graphical user interfaces, and the floor is for Ujjawal, if I pronounce your name correctly.
Uh, Good afternoon, everyone. I am Ujjawal Agrawal, an undergraduate student from Delhi Technological University. And today I will be presenting my work on SU2 GUI, having core functionality and a user-friendly installer. Some of you might be already familiar with what SU2 GUI is. It is a user-friendly graphical interface built using Trame, which is a pip library used to make web interfaces in a very easy and quick way. It basically simplifies the simulations we do in SU2. It allows easy installation through pip, comprehensive case management, real-time monitoring and visualization of simulations. Simulation initialization is also supported for restart files and uniform and patch initialization. In further slides, I will be presenting what's new in the SU2 GUI. Here I have listed them. Uh, so we have implemented a pip installer using which the user can simply install the SU2 GUI. The command is pip install SU2 GUI. This requires Python 3.10 or above. Using this command line argument is created, further using which the user can start the GUI simply from their terminal. With that, we have also provided command line arguments like the port on which the user want to start the server, case, case we will be discussing further, and also the path for mesh config and restart file, similar to what we already have for CFD solver. We have provided a comprehensive case management using which the user can start a new case, download a previous one, or delete previous cases. Loading of previous case is also provided. It basically loads the mesh file configuration or restart file if it finds that in the case, existing case, and load it into the GUI. This helps user to continue from where they left. Basically, the case is a folder in which all the files of that simulation are stored, like mesh file configuration, restart, and other V2 flow file. We also provide support for loading or starting a case via terminal. It creates a new case if it doesn't exist, or load the previous one directly into the GUI if it exists. Uh, Support for patch and restart file initialization is also implemented. Currently, we have box, plain, and sphere patch support, and both CSV and binary restart file can be used to restart the simulations from SU2 directly. Uh, Many users already have their own configuration file, which they might have built as a template. So we have added a support using which the user can load their configuration file and GUI sync that configuration file with the properties inside the GUI. And we have also provided a config tab using which the user can add properties manually or edit the previous existing ones and edit the description for configuration file. And there is always an option to check the configuration file data through the through this tab, and you can always reload it to the real time to minimize any uh, problem out there. We have provided support for error handling, like the real-time logs can be checked from the log tab. It basically have two tabs, SU2 and SU2 GUI. As you can see in SU2 tab, we have shown how the log which SU2 loads that are appearing. And SU2 GUI log tab has basically the logs from the SU2 GUI. And if any error or warning appears in any of these tabs, that appears as a pop-up, which awares the user about what's going on and what can be wrong. So these were some major tasks we have completed. And now I will be sharing how we can use SU2 GUI. A basic command like su2-gui can be used by the user to start the local server, and it provides the URLs which user can use. And in general, it loads into the browser by default. So using the URL is not required. This is the initial screen of SU2 GUI. It asks the user to load a case or create a new one. Loading or creating a new case is necessary for user to continue with their simulation, as we need a folder to store their files. Later on, mesh loading a mesh file into the GUI is important because we do require a mesh file for simulation, and configuration and restart file are optional to upload. And later on, user can use the left side menu to change the configuration for their simulation. After all this is done, user can go to config tab and review or update their configuration file for starting the solver. After this, the user can start the solver and visualize the results in real time using the geometry tab, and also they can monitor residuals through the history tab. And after, if you need troubleshooting during your simulation, you can definitely check out the log tab for seeing what is going on with the simulation. Once the simulation is completed, user can download or delete any case they require, which can be done through the case menu. And we have also provided an option to load previous case, or this basically loads all the files from that folder, mesh file, config file, and restart file, and user can continue from where they left. That's all for SU2 GUI. This is the workflow of how it works internally. Uh, Everything is stored inside a case folder, in which when the mesh file is loaded, it gets into VTK and visualization appears, and config is converted into JSON for further starting the simulation. When user starts the solver, using the JSON file, we create a config which later on used as a config file for SU2 CFD solver, which gives us the history and solution and other files which we can monitor from the GUI. So this was the workflow of SU2 GUI. Uh, we have done some testing using compressible and incompressible flow tutorials. As you can see, most of them are running, but we still have some unsupported parameters like marker Riemann and inlet file name, and we still don't support all type of file formats like CGNS. In very few cases, uh, this configuration can be there with the default value which SU2 GUI takes, like in laminar flat plate. We got odd results due to some default values which SU2 GUI takes. So it might require some manual changes through in the config file, which can be done through the config tab. Here are some limitations we have. Uh, Definitely some features remains unsupported and bug may be encountered. It still requires more testing, and configuration file for unsupported case may need manual changes, which can be done through the config tab. We currently only supports the SU2 CFD solver, which includes Euler, Navier, stocks, and RANs. We will be extending this further to other solvers. SU2 GUI has good growth potential. We can set up a server-side setup in which the GUI runs on a remote server and a user can load their simulation there. And later on, using cloud computation, we can do the simulation in a better and faster way, though that will require some computation. Uh, Next step, currently we do require to do some bug fixes and testing. Documentation is there, but improvements can be done in that also. We are planning to implement a SU2 installer, which basically install the SU2 also with the SU2 GUI. If the user doesn't have it, we will provide an option to install the SU2 directly from the pip package. In version 2, we can add the JSON validation for checking the parameters and various visualization improvements. In version 3, we plan to implement multi-zone CFD support, species information. At last, I would like to thank my mentors, Naizo and David, for their guidance and support throughout the project.
Thank you very much. Very interesting. Are there any questions from the audience, both online and present? Matteo,
So, let's take my name.
please. So,
Matteo P. Delft University of Technology. So, I'm part of this community since 10 years now. So, first of all, congratulations. This is a very laudable initiative. And by the way, I've seen the name of Nice and Ever. That also testifies their commitment. So
wow,
we
yes.
should also pay a round of applause later to both of them. But that's a question to you. The name I don't remember. Which one? Ujjawal.
Ujjawal.
So you basically have drawn a very comprehensive roadmap, right, regarding future development of the GUI. And we all know that it's a challenge to pick this up, not only because, it's difficult complex, it pays with the development of the tool. So basically to update the GUI to be compatible with the SU2. And knowing that, who will be basically helping you or others in continuing this endeavor? So what's the plan in terms of human resources?
Ujjawal.
Just a question to him.
Yeah.
I'm sorry, but that was not audible properly. Can you please repeat?
Yes, the question of Matteo is about the developments, the future developments. Do you have an idea of who will continue this work? Is there anybody together with you that will pick it up?
Actually, I'm just working with Evert and Naizo. This was my GSOC project. I personally will be continuing this project and will try to contribute to the community.
Wonderful. Thank you very much.
Just as a person suggesting one idea might be to like do like one of the checks for like after pull requests and case that not only like pass regression tests using STA's website terminal, but also check if your case relevant to what's like solely some bug fixes and additional options that you need to implement. And the result was the Google.
Yeah. Nice idea. Let's take notes. Yes. Any other question? Josh, again. We are becoming a serious conference now. All right.
So in the compile syncing process, I use this preventive for entering invalid options. We have a new file that lists all the possible options you can add that are valid. Is this in the UI or is it just get it wrong?
I'm afraid I'm not able to repeat your question, and I'm not sure Ujjawal heard it. Can you come here and ask?
Just go on now.
Yeah,
Feel free.
come here. Just a second, Ujjawal. Josh is coming. All right.
Hello. So my question was, in the sync file process, are users prevented from entering invalid options? So let's say, for example, you have a temperature boundary condition, can a user enter a negative value or something that's unfeasible?
Actually, we are planning to use the JSON validation pip package for checking the uh, arguments there are before starting the solver. But at the time of loading the configuration, at that time also we can check the uh, parameters using JSON validation.
Okay. Yeah. That's it.
Thank you, George. More questions? We do have a few more minutes. Name and affiliation.
Ujjawal from Polytechnico di Milan. So we use SU2 in our courses at university, especially the CME one. So I think this capability will be very useful to our students. So where can we find it, or where it will be maybe ready for the community usage?
Have you heard the question, Ujjawal?
Right, like where they can find the package, right?
Yes, it's particularly useful for academic education. So I guess we guess that could be quite a number of beta testers.
So anyone can. So if the user have SU2 in their computer, they can simply run pip install SU2 GUI command if they have Python. By doing that, they will be able to install the SU2 GUI, and they can run it there on their local host. And the code is currently available at my personal repository. It is also public. You can also check there.
And maybe a follow-up question. I'm not sure, maybe it's already clear to everybody, but have you tested this GUI on various operating systems?
Currently, I am testing on it on Windows, but I have to do it test on other operating systems.
Okay, so you haven't tested it on a Mac OS?
No, not on Mac.
All right, thank you.
But